Now, before I start today, what I've handed out is actually the take-home part of the investigation on next week. So you need to work through this week. Make sure that you understand what I've taught you in terms of bivariate data. Yes, Tom? Sorry? Yeah, validation is next week. Now, this one is basically for you go through very carefully thinking about the scenarios. All right? There's no actual data or anything given here. Okay? So next week they'll be given, you'll be expected to use your class pad to go through and do all the bivariate data analysis. All right? We will have time to do a bit of revision on Monday, Tuesday, because by Friday I want to finish teaching all the bivariate data analysis. Right? So this is for you to look at, think about it. You've got the whole weekend, the whole week to work through it. Now, what I'm going to do today is talk to you about the second last bit of bivariate data analysis. Important is actually to work on how to plot the residual and how to interpret the residual plot. All right? Step by step we are going through. Now, very quickly, by the end of the lesson, you should understand how to calculate the residuals for a set of bivariate data. Be able to construct a residual plot and be able to use the residual plot to determine if the data appears to be linear. Now, generally in terms of residual plot, for most of the exam questions I've seen is for you to plot only a couple of points, that's all. All right? So it's not expecting you to draw the whole residual plot, but you must know how to calculate it and plot it. All right? Now, let's start recap what we have learned so far. What you're doing in your investigation is basically the whole of this statistical investigation process. Think about collecting data, analyzing data, interpret, and communicate. Of course, you start off with a problem. Think about how you are going to present your problem. All right? A bit of writing involved, but think about what I've taught you so far. How you can write and define your problem, set up the questions, collect data, what sort of data you need to collect, how do you analyze step by step. Now, talking about analyzing data, what I've done is, this is basically a one-page summary of all the lessons that I've taught last 2 weeks of term 1. So using data collected, you must determine the dependent variable y and the independent variable x. All right, think about which one. And then, how do you plot it? This graphical representation, Callum and Arama. The graphical representation is scatter plot or scatter graph. You know how to do that already, right? And then you have to be able to use your class pad to derive the linear regression equation, which is y hat equals mx plus c, right? In that, you must also be able to determine the coefficient of correlation and coefficient of determination. Now, definitely in the exam question, when you are interpreting the strength, interpreting the data, you must thinking about, interpreting your regression and prediction, you need to think about the coefficient of correlation, whether it is strong or whether it's medium, or whether it's moderate or whether it is weak. All right? So if you have situation when it is moderate or weak, you may have to rethink about recollecting the data or reanalyzing the data or redefine the problem. Then coefficient of determination is the percentages of what variable explain the other. All right? So you must be able to interpret that. Now you also need to think about the equation. How do you predict? Whether it's interpolating or extrapolating, that sort of data. All right? Interpolation, it's more accurate because you've got the data set already. Whereas extrapolation is outside the data set, so it's not as reliable. Then it could have been you may have some confounding or lurking factor. All right, so these are the things that you need to think about when you're doing regression analysis until now. The next bit is talking about the residual plot and residual analysis. All right, so what happens is sometimes you may get a very strong correlation, but it may not necessarily be the linear regression. Although you can get a strong correlation and a linear regression equation, but the model itself, this equation is not good to represent the bivariate data. So that is where the residual plot comes in, why it is important. So what happened is, you have got a set of data. All these points here are the actual data. The observed or the actual data. And then you've got a regression equation, which is the predicted. All these green dots here that are plotted, they are the predicted data. So this is predicted using regression equation. You can see that when you predict the information, for example, when x is 2, the predicted information is pretty close to the observed. All right, this is a little bit further away. When x is 5, the distance is a bit further away. So what we need to do is to think about working out the residual. The residual is the difference between the data point and the predicted value. All right, so the observed data, take away the predicted value, will give you the residual. I'll give you the actual equation a little bit later. So this is the distance of a point from a curve, and it's positive if it is above the curve or the line, and it's negative if it is below the line, all right, or the curve. All right. Now, so this is important. The residual is the actual y value take away the predicted y value. So the actual data take away the predicted data. All right. So you will be given the actual data in terms of a table in the exam, in the test, or in the investigation, or you may be required to read it from the scatter plot. Then the predicted data, you need to use your class pad to come up with your linear regression equation. All right, any question? So far so good? I'll move on to showing you how to plot the residual. Now, so what you need to do, you need to calculate the distance. That is the residual. So this is the residual when x equals to 3. So the actual data, the actual point here is 6. So at this stage, I estimate that as 3.5. So the distance is 6 minus 3.5, which is a positive. 6 minus 3.5, approximately 3.5 or 3.6. Let's say 3.5. And that is 2.5. All right, that's residual. Whereas this one will be, this is 2 minus, that is, let's say 4.2. So that's minus 2.2. So you can estimate the residual from a graph like this. Generally, you don't. You'll be given the actual data point. You'll be given a table for you to fill in. All right? So the important thing to know that the further the actual value is away from the regression line, the larger is the residual value. All right? Now, so first, let's have a look at this example. The regression line connecting h, height in centimeter, to h, a in years was found to have the equation h hat. This is the estimated value of height equals 100 plus 2.58. Now, you need to calculate the residual value for John, who is 12 years old and 142 centimeter tall. So part A, what you need to do first is to work out what the estimated h is. So h is 100 plus 2.5 times 12. All right, I need my calculator. So it's 100 100 plus 2.5 times 12. You can use your calculator and work it out as well. So it works out to be 130 centimeters. That's the estimated age. All right, the predicted age. So therefore the residual is 142 minus 130, which is 12 centimeters. All right, make sure that you know your unit. Can you try part 2, please, Jane, who is 10 years old and 108 centimeters tall? Try that, please. Now the residual here is minus 7 centimeters. Part B, calculate the actual height of Johan, who is 14 years old, and the residual is 8 centimeters. All right, the residual is in. So H, part B, work out the estimated age is 100 times 2.5 plus 2.5 times 14, which is 135 centimeters. Now you know the residual is 8 centimeters equals actual, take away predicted, and the residual is 8. Actual we don't know, take away 135. Therefore, the actual height is 143 centimeters. Right? So you must be able to use your regression equation to calculate the residual, or given the residual, given the equation and the residual, calculate the actual. Pretty straightforward, yeah? Now the next thing is knowing how to calculate that and plot a residual plot. All right? Okay, now look at all this graph. So you've got, starting off with graph A, which is a scatter plot. You've got a scatter plot which appears to have a strong negative relationship. This is a step by step. All right? Step 1, you do the scatter plot. Step 2, you come up with a regression line. All right? Once you've got a regression line, you look at this. You know that the RXY, the correlation coefficient, is minus 94, which is very strong correlation. And then what you need to do is work out the residual and plot the residual. Now notice that the scatter plot and the residual plot, X is always the same. X must be the same for the scatter plot and residual plot. All right? The residual is going to be different because you got a positive and negative value. It must have a positive and negative value. If everything is positive, something is very wrong. Or it is not. If everything is positive, something is either very wrong or it is not a linear relationship. All right? So here you can see that there's actually no pattern. Now, in terms of residual plot, x-axis is the same as the scatter plot. Y-axis is the magnitude of the residual. So therefore, it's sort of the same information as this. However, you're just taking the vertical distance. That's it. Right? Now, here we will learn how to interpret the residual plot. In this case, you can see that there's actually no pattern at all in terms of this residual plot. It's very scattered. It's all random, all over the places. Now, the next example. This one, you got a scatter plot. you use a regression equation, and you found that it is a very strong correlation, 0.83. All right? Then you started working on the residual. Now here, the residual actually has a pattern. All right? The pattern is such that it looks like a parabola. It's not scattered. It's not random. All right? When the residual plot is not random, what I would say is this linear regression line is not representative of that set of data. It's not a good model. All right? So you need to be able to interpret the residual plot. The residual plot will show a pattern. If there's a pattern, which means your linear regression line, although I've got a very strong correlation, cannot represent the data well. All right, another example. This is another example. Again, scatter plot. It looks straight away, you know that it's not non-linear. However, when you work out the correlation of coefficient, it's very strong, 0.92. You can still get the regression line. But this time, again, there is a pattern. It's a parabola. It's a U-shaped pattern. So you can see that those two, there's a pattern, and also there's a pattern. You can always describe there's a pattern by saying that between 1 and 3 or 1 and 2, the residue is negative, and then between 2 and maybe 5, the residue is positive, and then it's then back as a negative. And it has a pattern, and it looks like a parabola. All right, know how to describe it. Non-random nature, or use the word non-random nature of the distribution, or random. All right, so this is basically the summary. Correlation coefficient on its own is a very poor indicator in the validation of a linear regression model. And on its own, it cannot be used to justify a linear relationship between two variables. So although it's strong, but it may not necessarily be linear. A residual plot will allow us to determine the validity of the linear regression model as a predictor. All right? The word validity is important. And the residual plot should be a random scatter of points in the plane to show the line of best fit is linear. So you need to be able to use the word random, all right, and may use the word of valid. All right. Any evidence of a non-random distribution or exhibit a pattern, for example, parabola pattern, in the residual plot will indicate that the linear regression model is not appropriate. All right. The magnitude of the residuals give us an indication of the strength of the linear relationship between the two variables. The smaller the magnitude of the residual, the higher the correlation between the two variables, resulting in an increasing reliability of any predictions that may be made. All right, now, this one, I would like you all to grab your Clark book out because I'm using the example in Clark. Instead of me photocopying it, I'm just using an example in Clark. Yes. Did I say that? If there's a pattern, it's not appropriate. The word not. There's a pattern. If you look at the residual plot here, there is a pattern. There is a pattern, so it's not appropriate to use it as a linear. Whereas something like this, there is no pattern at all. It's scattered all over. Therefore, it's considered as appropriate. All right? Yeah, this one, there is a pattern, a U shape. Yes?
What's the magnitude?
Magnitude is the distance. Is the distance between whether it's the magnitude of it is the distance between the predicted and actual. So what I would like you to do is to grab your Clark book, please. So I'm going to use example page. It's exercise 3E, I think. Yep, exercise 3E. Pretty sure. Yes, exercise 3E, page 75. Question 3A. Alright? Question 3A. I'm going to use that as an example. Now, you need to be able to plot the scattergram using a graphics calculator and comment on the linear relationship between the variable. Instead of plotting it on a graphics calculator, I'm going to go through and ask you to plot it on a graph if you have the time. If not, you just have to follow me step by step. Now, you should be able to use your calculator to determine the coefficient of correlation and determine the equation of line of best fit. Alright, can you do number 2, number 3, and number 4, please? You should be able to use your equation to predict y hat and then y minus y hat. Give yourself a few, maybe about 4 minutes to do that. Let's not worry about plotting the scatter graph first. Let's just do 2, 3, and 4 first. Alright? Determine the coefficient using your calculator. Determine the equation of the line. And then calculate y hat. Alright, I've just got an email about dress code. I've got to remind all of you, please wear your proper uniform. Once you do 2, 3, and 4, you should be able to plot the scattergram using the graph, using your class pad. All right? You should have a. Who hasn't got a book? If you haven't got one, I've got spare. Yep.
Is the residual essentially synonymous with the accuracy?
Sorry?
Is the residual synonymous with the accuracy?
You got your book? You got your book? Who hasn't got a book? Yep, okay. All right. Now, this is what I've done. Hopefully, it's the same as yours. All right. So I worked out R is 0.9979 and Y hat is 2.0371 plus 1.42. Once you've done the plot on your calculator, you can see that is pretty much a linear relationship. Very strong positive linear relationship. Like I mentioned, always give 4 decimal places for the gradient, and this one in this case, you have no choice, it's only 2 decimal places, 1.42b. Alright? Once you've done that and plotted, you should be able to use your regression line, 2.371 plus x plus 1.42 to determine your y hat. Alright? This is how you do it. So when x is 1, it's 2.371 times 1 plus 1.42. And then you can work out the residue. All right? Yep.
Mine take 2.04 instead of 2.037.
You would have inputted one number incorrectly. That's all. It happens. It happens. All right? So, filling in everything, you should get the same number as I do. About that. I know it is a bit hard to plot all this. What I'm going to show you is how I plot my residue. So this one here, y minus y hat, that is your residue. Your residue. Alright, so this is your scatter graph. I've done it again, plot it nicely, and I draw the line of best fit. Now, remember, when you draw the line of best fit, always indicate the 2 points that you use. Alright? I should have written down that point would be 1 and 3.4571. This is 1, 3.4571, and this is 6. I can't remember what it is. 13.6426. Alright? Now, make sure that when you draw your regression line, it's not by eyes. You must plot the 2 points. It doesn't matter which 2 points. You can use that as well as the y-intercept, that's fine. Not a big problem. Alright? And then when you plot your residue, make sure that you've got the word residue there and you've got your x there. You can see that in this case, it's actually random. Sometimes some book will join the dots to show you that it is random, but you do not ever join the dots at all for residue plot. Do not join the dots. Just show that it's random. Now, if you want to use ClassPad to plot residue, that's fine as well. This time, you've got your input data. Alright? What you need to do is, you go to Set Graph and click on Stat Graph 2. Let's try it together, please. You've already got your data in. Alright? Input the data, go to Set Graph, and click on Stat Graph number 2. And then you go to number 2, Stat Graph. Make sure that it's scatter graph, please. Number 2 is scatter graph. Alright, under Set Graph, number 2 is scatter graph. Start off with Set Graph, Scatter Plot 2, Scatter Graph 2, Stat Graph 2, and then make sure that 2 is scatter graph. From there, same thing, calculation, linear regression. The slight change is you need to copy your residue into list tree so that you got your lab residue information in the list tree. Now, this step is important. Copy the residue into list tree means that if you're asked to calculate the residue, you don't have to work it out. It's all there. You can just copy it down, that's all. Alright? This step is very important. So once you've done that, you can see that after all this, you've got your residue and it plotted the residue for you. Try that, please, everyone. Try it, please. Alright? So now the next thing is if you want to go back to your scatter plot for your data, you must make sure that you turn off scatter plot 2, scatter graph 2. Alright? If you want to plot your scatter graph for list 1 and 2, make sure that you turn off StatGraph 2. If not, it will not work. Alright? If not, it will not work. Yep. I'm finishing soon. Alright, so what I've given you today is how to plot residual plot, how to calculate residual, and using your class pack to work out residual. So you don't actually have to work out all the numbers. You can get a residual straight away. Alright? Now, here, the last slide, this is an important one. Interpreting the residual plots. You need to know what residual is. Actual Y value, take away predicted Y value. And then actual Y value can either be stated, be found in the data table, or read from a scatter plot. Alright? Predicted Y value from Y hat equals to AX plus B. This one is definitely random. Make sure that you use the word random pattern. Answering question, always use the word random pattern. I'm going to highlight it here. The random pattern indicates that a linear model provides a decent fit to the data. And use the word non-random. If you want, of course, you can describe it as a parabola. Alright? But sometimes it may not be. Alright? So just make sure that you use the word non-random pattern, suggesting a better fit for a non-linear model. The word non-linear model is quite important. You can use that. Alright? Now, so today I've shown you how to calculate residual, and you should be able to construct a residual plot and be able to use a residual plot to determine if the data appears to be linear. So exercise 7E, and we'll go, sorry, not 7E, 3E, is that right?
Yep.
Yeah, exercise 3E. We'll go back to 3D on Friday.